Students, is my screen visible?
Yes, ma'am.
Okay,
Yes, ma'am,
thank you.
visible.
Good evening, ma'am.
Good evening. Okay, good evening everyone. I am Rakhi Yadav, your PMRF teaching assistant for Introductory Organic Chemistry course, which is conducted by NPTEL and whose course instructors are Professor Harinath Chakrapani and Professor Neeraja Dashaputre from ICER Pune. So, students, in this week 4, we are going to cover problems based on carboxylic acid and its derivatives, and with some introduction of alcohols, ethers, and epoxides. Before moving to today's class, can anyone tell me what topic we have covered in last class? Nucleophilic addition of on carbonyl compounds, right? So, in last class, what we have done, who is going to revise, recall after me? That we have studied in last week nucleophilic addition on carbonyl compounds when that carbonyl group having alpha chiral center. Yes or no? There we talked about three models. First one was,
Falcon's model,
second,
Graham's model,
second is your Conforth model, and third is your
Conforth.
Kramskilation model, right? In Falcon model, what we have to do, we have to keep a large group perpendicular to C double bond O, right? And in Conforth model, let's say if on that chiral center we are having heteroatom, so we have to keep that heteroatom perpendicular to C double bond O. And last one was Kramskilation model. In that, what we have to do, we have to keep that heteroatom adjacent to C double bond O, so that that metal. And for Kramskilation model, what condition was necessary? That cation should be bivalent, yes or no, so that it can
Yes, ma'am.
coordinate with carbonyl oxygen and with that heteroatom. Okay, so in the end of the class I am going to ask all these. Before that, let's start today's class. So, as the name suggests, carboxylic acid is acid of organic chemistry. If we talk in terms of chemistry, in general, inorganic acids are more strong. Yes or no? But in case of organic acids, we have to go via a certain sequence. See, a basic definition of acid is, if you write a reaction, let's say you have HA, okay, it will dissociate into H plus A negative. You know from your 12th standard that more stronger is your acid, more will be the concentration of H plus release, right? When acid will release H plus more, when its conjugate conjugate base will be stable, right? Let's say they are two friends, or let's say they are couple, when they will love to live separately, when they will be stable in their own life, yes or no? So more stronger is your stability of conjugate base, more stronger will be your acid. Okay, so now how to see stability of these conjugate base? So in organic chemistry, whenever you are given that, uh, tell the order of acidic strength. So how you have to go? You have to see first stability of conjugate base. And what is conjugate base? So let's say you are given CH3COH. Okay. So its conjugate base will be CH3COO negative. So can anyone tell me what will be the conjugate base for H3PO4? Quickly.
H2PO4 minus.
Very good. So, if anyone asks you what is conjugate base, you just have to remove one H plus and put one negative there. Conjugate base of H2PO4, H2PO4
H
negative.
HPO4 die negative.
Exactly, HPO4 di negative. Conjugate base for HPO4 2 negative.
PO4 tri negative.
Exactly, PO4 tri negative or 3 negative. But let's say someone asks you conjugate acid for PO4 3 negative, then you should tell them HPO4 2 negative. Okay, reverse. Conjugate acid for HPO4 2 negative, H2PO4 negative, right? So if you are clear in this, tell me conjugate base for H2O. Conjugate base for H2O.
OH
OH
minus.
negative. Okay. So good. So just wait a minute. Now the sequence which I am going to tell you, you have to see the stability in same order. You will always get correct answer. So you have to see in that sequence. So how to see acidity? Or I can say stability of conjugate base. First, you should see size, then your electronegativity. Third is your resonance or mesomeric. Fourth one, you should see what? Hyperconjugation. Then your inductive. That's all. Okay. So in this order, you have to see stability of conjugate base. Now let's say I am saying you CH3OH means methanol, and this is your CH3SH. Okay, so if I'm asking among A and B which is more acidic, so first what you will do, you will form their conjugate base, and then you have to see stability, right? So let's see one by one. First, I have told you that first you should see size of that anion. So if we talk about anion size among oxygen and sulfur, which is bigger, sulfur or oxygen?
Sulfur.
So it is clear that CH3SH is more acidic than your methanol. Understood? Second, you have to see electronegativity factor. So let's say I talk about HF and H2O. So what you will do? You will first make conjugate base of both. Now see how I'm watching, how I am seeing the stability of conjugate base, that this anion is on which atom? Here this anion is on fluorine, here oxygen. Among fluorine and oxygen, which is more electronegative?
Fluorine.
Exactly. So more acidic will be your HF. Now someone will come and ask me, ma'am, what about size? So see, in period from left to right, you should see only electronegativity. Why? Because there is no significant size difference. Yes or no? So in
Yes, ma'am.
period, you have to see electronegativity, but in group, a new shell add. So there you have to see size first. Okay. So size, electronegativity. Then comes about your resonance. So let's say there are two examples. Uh, COOH. Okay, here I have. Okay, we will see those examples later, but you have understood, right? First, you have to see size factor, then electronegativity, then your resonance. Okay, in resonance, or let's say mesomeric effect, which groups are going to increase your acidic strength? Plus M or minus M? Okay,
Minus.
minus M, because plus M groups are those which increase electron density, right? And minus M, they withdraw electron density.
Yes, ma'am.
Hyperconjugation, you have to see alpha hydrogens. And for inductive, plus I will decrease your acidic strength and minus I will increase your acidic strength. Why? Because you have anion. How will you make anion stable? By decreasing that negative charge. How will you decrease that negative charge? When you put any group which will withdraw electron density from it. Okay. Okay, if you understood all this theory, then tell me the correct decreasing order for acidic strength is. Take 30 seconds time and tell me the answer.
Ma'am, option 3.
Option 3. Other answer? Are you sure option C? Yes, na? Be confident on your answer.
Yes,
Yes.
ma'am.
Option C is correct. Why? Because let's say you have make conjugate base of everything. Then this nitro, what it is? Minus M. Right? This is minus M. Okay. This is minus I. This is minus I. But I know fluorine is more electronegative, but I have told you in last class or electrophilic aromatic substitution class, fluorine is plus M group also, right? And you can see that priority wise mesomeric effect comes ahead than your inductive. Okay. So therefore minus M group will come here, and in minus M also nitro is more electron withdrawing group than your nitrile. So NO2, CN, then fluorine and chlorine, right? And for inductive you should remember this theory DNP, distance, number, power. Here what factor comes into picture? Power. Fluorine have more minus I effect than your chlorine, right? Okay, if you understood this theory, let's say here COH, here COH, okay. And here I have taken fluorine and here I have taken 2 chlorine. Now tell me among A and B which is more acidic? Among A and B. If you understood DNP in inductive.
Ma'am, B.
Yes,
B.
why? Because it is more in number. You should always apply this thing. Distance, number, power. Distance means how much carbon away this group is attached. Okay, this is your distance. So distance, number, power. And for acidity, size, electronegativity, resonance, hyperconjugation, inductive. Okay, good. This is your second question. When the CH2 double bond CH acid is reduced with LiLH4, the compound obtained will be. Your options are first acid reduced to alcohol, second completely reduced product, third is your aldehyde, and fourth is your double bond reduced product.
Ma'am,
LiLH
option B.
option
Option 2.
2.
C.
Okay, some are saying option 2, some are going with option 1. Okay, if you talk about LiLH4, this is your LiLH4, right? Now, if you talk about boron family, right? Boron, aluminium, and so on. They are in which group?
13th
Third,
number.
13.
third, 13. Very good. Boron is your 1s2, 2s2, 2p1. Okay. So basically they have vacant orbitals, right? So that's why boron compounds are electron deficient if you have seen. Just wait. So aluminium will follow same property as your boron is following. Hmm. But one problem is there with these compounds. When they have three bonds, they are electron deficient. They are in too much need of one electron pair, right? But another problem with them is when they have four bonds, negative charge comes on them. Okay. So in order to decrease this charge, what they do is they donate hydride. Okay. And then they will again go back to their ALH3 form. So whenever you are having carbonyl compounds, right? Let's say you are having this carbonyl, simple ketone. So first step is this carbonyl reduction. This will go with H. Now you know that after giving hydride, this ALH4 negative change into ALH3. Now again it has become electron deficient because it is having three bonds. Now what it will do? It will coordinate with your O negative, right? Al, H. I will speak again, okay? If anywhere you are having doubt, just tell me. Okay. Now again minus charge will come on this because now aluminum has four bonds. Yes or no? So what it will do? Another carbonyl group will come. I am just telling mechanism of LAH reduction of carbonyl compounds into alcohol. Okay. So after you get this compound, another molecule of carbonyl will come, and this molecule will donate one hydride. Yes or no? And what it will become? O Al H H this. Correct? And then this aluminum complex will again coordinate with this oxygen. So if you understood this mechanism, can you tell me one mole of LH, 1 mole of lithium aluminum hydride can reduce how many carbonyl groups? I'm repeating my question.
Four.
Four. Okay. So
Yes, ma'am.
in simple language, what it will do? First, it will donate hydride to carbonyl, and that aluminium will bind with oxygen. Then in next step, this this is going to donate one hydride to second carbonyl and will form complex. You do it as your homework. You draw the mechanism. Wait. You do take it as your homework. You draw here, and this complex is getting coordinated with this oxygen and donate one hydride here. At last you will get one complex in which this oxygen will be fully occupied by your aluminum, right? Then after hydrolysis you will get your simple alcohol. Okay. If you are not able to write mechanism, remind me in next class. I will give you complete mechanism. But I hope you have understood what it is going through. Simply transferring one hydride and getting reduced. Okay. Yes or no, students? For now, you may remember that LiLH4 reduce carbonyl compounds into alcohol. Yes or no?
Yes, ma'am.
Yes, ma'am. Okay. So, in problem number 2, compound 1 will be your major product. It will not reduce that double bond. Why it will reduce double bond? But if you get any cyclic system like this, now you tell me, let's say in one condition you have taken LAH, lithium aluminum hydride, and in another condition you have taken NaBH4. Now can anyone tell me about A and B? Okay, think about this question. We will discuss this question at the end of the class. Okay, you have your cyclopentanone. In one condition you are treating with NaBH4 and another LAH. Okay, and you should note this thing that your LAH, lithium aluminum hydride, is more reactive than your sodium borohydride. Okay. Problem number 3. Among the following acids, which have the lowest pKa value? So before that, you should know about pKa. pKa is, student, basically minus log of
K.
K. Okay. Why minus log K? Because K is in terms of, let's say, 1 into 10 to the power minus 5. Okay. Let's say you are having log 10, 1 into 10 to the power minus 5. What will be its value, students? Minus 5. Yes or no? Base 10 and in bracket 10. Okay. Let's say you are given log base 10, 10 to the power minus 7. What will be its value? Minus
Minus
7.
7.
Huh.
-7.
I hope you should know these basic things. Huh. That's why this minus sign is there. Okay. So one thing here it is clear that let's say this is Ka1 and this is your Ka2. I'm asking which is greater, Ka1 or Ka2. I'm asking about Ka, not log or pK. Ka1, Ka1 is more, right?
Yes.
10 to the power
Yes, ma'am.
minus 5 is more than your 10 to the power minus 7. Basic
Yes,
maths.
ma'am.
Huh. Okay. But if you say pK, pK of first one will be 5 because negative negative plus 5. And pK2 for second one is your 7. You can see this trend, right? More is your pK, lesser will be the pKa, right? I'm writing here pKa is inversely proportional to your Ka. Yes or no?
Yes, ma'am.
Huh. So and pKa will be inversely proportional to your acidity. Higher is your compound acidic, lower will be its pKa. Therefore, stronger acids have pK in range of 1 to 2, if you remember. Have you studied ionic equilibrium or chemical equilibrium anywhere?
Yes, ma'am.
Okay, just revise those concepts. So I am basically telling here that higher will be your higher the strength of your acid compound, more will be its Ka and lesser will be its pK. Okay. So now tell me, keeping this thing in mind, among these following acid, which is having the lowest pKa value? Lowest pKa value means strongest
Highest
acid.
strength
Huh.
of acidity.
Now tell me which is most acidic. And
Ma'am,
for
B.
option
Two formic.
option 2, very good. Which order you have followed here? Obviously, size same in everything. The next factor was electronegativity. Oxygen is same in both, so you can't apply this. Third was your resonance. You can't apply inductive. Now it comes about inductive. So this is your 1 degree carbon. This is your 2 degree. This is also 1 degree. So your most strongest acid will be HCOH and least highest pK among these four options, which will be having highest pK value?
Option number 3.
Option number
Third option.
third. Very good. Understood now? Why?
Yes,
Because that
ma'am.
is 2 degree. Higher will be your plus I, lower will be your acidity. And you have understood this relation between pKa and Ka. That inversely proportional relation due to this negative charge. Okay. Actually, this negative charge is put here in formula just to what I will say, simplify the things. Okay. Okay. So in problem number 4, paracrisol reacts with chloroform in alkaline medium. Okay, let me write. Okay, before that, tell me what is paracrisol. In 12th standard, this nomenclature is there.
Yes, ma'am.
Tell me
Ma'am,
what.
uh,
Huh?
I think a hydroxyl group is induced into a toluene.
Very good, very good. But paracrisol means your methyl groups and hydroxy groups are para to each other. In
Yes, ma'am.
metacrisol, they will be meta, hydroxy and methyl. In orthocrisol, they will be ortho. Okay. So
Ma'am, it is induced into a toluene or it is induced in phenol? Means a
I
myth.
I think no, not induced, but uh, crisol basically it's nomenclature for phenol compound having methyl groups, right?
Yes, ma'am. Okay, ma'am.
So this is your parachloroform. They are saying you should treat with them in chloroform Now you are seeing now we have jumped from carboxylic acid to alcohols. Uh, which name reaction is this? To give compound A. Then they are saying A on adding hydrogen cyanide, they are giving compound B. Then they are saying the latter on acidic hydrolysis gives chiral carboxylic acid. The structure of carboxylic acid is. Before starting this question, tell me what is the first step or what is the name reaction involved in first step? Okay, let me give you hint that name reaction starts from R.
Remer-Timmer reaction.
Huh. So what is the reactive intermediate of that reaction? Okay. You have chloroform, right? CH, Cl, Cl, Cl. And you have base. You on arrow you have these things, right? So only thing that comes into your mind is that base is going to abstract this proton. Yes, yes or no? So after getting proton abstracted, this will form. Now you know that chlorides are very good leaving groups, right? So it will go as Cl negative. And whenever you are having one negative and one positive charge, that is your carbene, 6 electron species. It can be written like this with one non-bonded electron pair, CClCl. Have you guys understood till this point how I have made this carbene?
Yes,
First,
ma'am.
base is going to abstract this proton, negative charge will come, chloride will go as a leaving group, and you will get this carbene. This carbene can be written as in form of this negative and positive also. Now, what you will do? Since basic media is there, this will become O negative, right? And then O negative will come down, and from this alpha position, it will attack this carbene. Now, can anyone tell me what charge will remain on this carbon, positive or negative?
Positive.
Positive.
Positive. Are you sure?
Yes, ma'am.
Why?
Ma'am, tetravalency is not fulfilled here, and
See, you are having this reactive species, yes or no? When oxygen negative charge will come back, O negative will come back, this carbon is going to have which charge? Negative charge. That negative charge will attack this positive charge. The remaining charge on carbon is negative. Yes
negative.
or no?
Okay, ma'am.
Understood?
Yes,
Students.
ma'am.
Huh.
Yes, ma'am.
Now, what will happen? Obviously, it will abstract this intramolecular proton transfer will take place. Why? Because this will be more acidic position, right? It as it will be in resonance. So I will write it as intramolecular proton transfer reaction. I am giving here mechanism in short. You go home and just study the mechanism for Remer-Temin reaction. Okay. After intramolecular proton transfer reaction, what will happen? It will undergo resonance and will form O negative, right? And you will get here CCl2. Now NaH is there in your reaction vessel. This chlorine will be replaced by your OH. Yes or no? And this at last what it will form? What is the product for Remer-Temin reaction? Orthosalicylaldehyde. Yes or no? And this methyl will be also there. I hope you understood first step. If not, just tell me where you have problem. I will explain again. Students, have you understood or I should explain again? Okay, I will explain again. So at first in on arrowhead it is given chloroform and sodium hydroxide are there. So first step for our first aim of this base is to abstract this proton. It will abstract proton and negative charge will come on carbon. Then chloride will leave as Cl negative, leaving positive charge here. Formation of this reactive intermediate, that is your carbene. Carbene is equivalent to having carbon having both negative charge and positive charge. So in basic medium, this will become phenolate ion, means O negative. This O negative will come down. This bond will shift here. This carbon will be having negative charge. That negative charge attacks onto this positive, and this negative, as I have already told you, that in carbon, this carbon is having both charge, negative as well as positive. This positive charge is quenched by this alpha carbon of phenol. Remaining charge is negative. Now this anion will abstract proton of here. Okay. Negative charge will come here. It will again go and aromaticity will be back. Right. Now you are having two chlorine that will be substituted by your sodium hydroxide OH, and after removal of water you will get this aldehyde, and this order after Remer-Temin reaction at alpha position CHO will be introduced. Now tell me, is it clear or I should clear na, or I should explain more slowly? Students, yes or no? If not, I will explain again on a new slide.
Ma'am, please, new slide.
New slide, okay. Just tell me, are you clear till that point? Intermediate, reactive intermediate, CCl2. Okay, I will write it again. I hope you all are clear till this point. Formation of this reactive intermediate. Just say me yes or no. If not, I will explain again. Yes or no.
Yes.
Okay, okay. Let's start with simple phenol. Okay. In your reaction medium, sodium hydroxide is there, right? Sodium hydroxide is going to abstract this proton. It will become your phenolate ion, right? I have told you that this carbene can be written as one pair of negative charge and one positive charge. Okay. This negative charge will come back and will attack this positive, right? So what you will get? Double bond O. If oxygen negative charge will come back here, this carbon will be having positive charge, right? Sorry, negative, this carbon. And it will attack this carbene. Okay, if negative charge come here, it will attack obviously this positive charge. Is this clear to you? That when this negative charge will come onto this carbon, it will attack this positive charge. Yes or no?
Yes, ma'am.
Okay.
Yes,
So
ma'am.
the remaining charge will be negative. See,
Yes, ma'am.
for
Yes, ma'am.
understanding,
Understand.
purpose, I am telling you that you can treat carbene as positive charge and negative charge, but in real they are non-bonded electron pair. Basically, your carbene is first electron deficient, but since it is having both charges, positive as well as negative, positive charge gets quenched by this carbon ion, and this charge is left as it is having both the charges. Now, students, This hydrogen is remaining here. This carbon ion will take this proton as H plus. If it takes as H plus, this carbon will be having negative charge. Yes or no? C H Cl Cl, and negative charge will be here. Till this point, yes or no? If if I'm clear to you, say yes.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Now this negative charge will again go there and aromaticity will be back. When you write this mechanism by your own, na, you will understood. CHCl. Now you have sodium hydroxide in your reaction vessel. Chlorides are better leaving group. Yes, so they will be substituted by your hydroxide ions. Yes or no? O negative, C, OH, OH. Understood? Now one molecule of water will leave. If it will leave, what it will form? Basically, okay, look. O negative, CHO. Right? Okay. Why I am writing this? Let's say you are having aldehyde. When you treat it with OH negative, you will get this species. Yes or no? O negative OH. So this is same species now, O negative OH. Because in presence of base, it will form O negative OH. Yes or no? So it is equivalent to your aldehyde. So after workup and all, it will become your CHO and this will become your OH. So basically, we have done this conversion. Whenever you are having phenol and on arrow it is written that chloroform and sodium hydroxide, your instant answer should be that 2-hydroxybenzaldehyde is your product. Now tell me, is it clear or still it is not clear? I can't explain above than
Clear, ma'am.
this. Are you sure?
Yes, ma'am.
Yes, ma'am.
Or for right now, in your level, just remember this thing that phenol on treating with chloroform and sodium hydroxide will give you orthosalicylaldehyde. This compound have a more common name, that is salicylaldehyde. Go home and read about this mechanism on Google, okay, or any standard textbook. I will prefer you read Claydon, okay.
Yes, ma'am.
Okay, if understood. Problem number 5 for today's session. Tell me first product A quickly, very easy question. Have I taught you or sir have taught you the about reducing agents, lithium aluminum hydride and all, yes or no?
Yes, ma'am.
Okay, then tell me. Basically, LAH, if you are having your ketone, it will form alcohol. If you are having your, let's say, aldehyde, then also it will form alcohol. If you are having carboxylic acid, then also you will get your alcohol. Okay. But if you are having amides, then what you will get? Amine. And your homework is find mechanism for this. LH reduction of amides to amine. Okay, we will discuss this in next class. So for now, you should remember this. Whenever you are having carbonyl compounds and on arrow it is written LiLH4 or in short form LAH, you should directly make alcohol of that carbonyl compound. Okay. So in
Yes, ma'am.
so in first step, your product will be CH3 CH2OH. Number of carbons should be same. Okay, remember this thing. Okay, PCl5, chlorinating agent, right? So it will
Yes,
form
ma'am.
CH3 CH2 Cl.
CH2Cl.
12th standard question it is. Now C, after alcoholic KOH, it is not aqueous KOH,
Yes, ma'am.
alcoholic
Alcoholic QH, then it will be
elimination.
ethyl
CH2 double bond CH2.
CH2.
If on arrow it is written aqueous KOH, then you will form CH3 CH2OH. Okay. Alcoholic KOH. Okay. Let me write here. You can write in your notebook. Alcoholic KOH leads to elimination. Aqueous KOH leads to substitution. Understood? Okay. Problem number 6 is a good problem. Compound A, C8H9Br, gives a white precipitate when warmed with alcoholic AgNO3. Okay. Then they are saying oxidation of A gives an acid. That acid easily forms anhydride on heating. Identify the compound. Now your first question should be how to start solving this question. Okay. This is looking difficult but it is not. I will suggest you do these questions by option. They are saying by option means you don't have to draw many structures for C8H9Br. C8H9Br means one phenyl ring is for sure it is there. Okay. Another thing I have told you in last class, double bond index. Okay. Can anyone tell me how many double bonds are in this molecule? Let me give you formula. C minus H by 2 plus N by 2 plus 1. And here monovalent atoms should also monovalent atoms are also there. Monovalent means fluorine, chlorine, bromine, iodine. Now tell me double bond index of this molecule. Quickly, I am also solving. 8 minus 9 plus 1, 10 by 2. Nitrogen is not there, so 0 by 2, so plus 1. 8 minus 5 plus 1, 4.
2.
2, how you get 2?
Ma'am, 8 minus 6, no?
8 minus 6, how? This
Okay,
is,
okay. I
huh,
just know that mine. Okay, ma'am. Okay.
okay. 4. If anywhere you are getting double bond index or degree of unsaturation 4, your quick thinking should be that it is your benzene, right? 3 double bonds and 1 ring. Okay, it means your benzene is there in your molecule. Let's say you are not given this option. So, how would you approach this question? First, you should know how many double bonds are there in my molecule. Okay, then their next statement is this compound gives a white precipitate when warmed with alcoholic AgNO3. White precipitate AgBr. It means Ag here is in Ag plus form, right? After taking Br negative, it will form AgBr and that is giving white PPT. Yes or no? It means it will leave positive charge on which carbon. It means after taking Br negative, here it will be positive charge, positive, 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 positive. Okay. After watching or after reading this line, gives a white precipitate with AgNO3. Which option we can delete instantly?
Option 2.
Option 2. Why? Because this carbocation is not stable on sp2 carbon, right? All other carbons are sp3 on which carbocation is there. Yes or no?
Yes, ma'am.
Others understood? Once this Br negative will leave, it will form your carbocation. Yes or no? Why others are silent? Is it very hard?
Yes, ma'am.
Okay. Yes for easy na. Okay. Oxidation, then they are saying oxidation of A gives an acid B. Now you can see that there are O4. It means there are two carboxylic acid in your molecule. Okay. So this can be carboxylic acid, this and this. But last they are saying easily forms anhydride on heating. It means they are ortho to each other. Okay. So in first step, it will take your AgBr and will form CH2 positive Br CH3. Okay. And okay, this Br will not be there. And let's say after hydrolysis it came CH2OH. Okay. Then under oxidation condition, what it will form? COH, COH. Okay, let me tell you this thing. Students, whenever you are having benzene ring with alkyl groups attached here, long chain of alkyl, and on arrow it is given KMNO4, you simply write benzoic acid. Okay, COH. Understood? So after
Yes,
getting this, you will form anhydride easily. Anhydride is nothing but your C double bond O, O. Yes or no? So which option is correct among all these? Option number
fourth.
4. Boys, why you are silent today? What happened? Am I explaining that bad? Who is responding right now in girls? Dipali.
Yes, ma'am.
Huh. So excluding Dipali, no one is getting what I am explaining to you? Or I should go slowly? Tell me, I will explain in that pace as per your convenience. Okay. Problem number 7. Which compound would give 5 keto 2 methyl hexenol upon ozonolysis? So, your first step after reading this question is just draw that structure 5 keto 2 methyl hexenol. So, hexenol 1, 2, 3, 4, 5, 6, 7. I think 7 carbons are done, right? Okay. Hexenol, sorry, not 7, 6 carbon should be there. 5 keto. 1, 2, 3, 4, 5. 5 keto. 2 methyl. 2 methyl. Upon ozonolysis. But one thing we have, okay, now it is correct. So we will start numbering from where functional group is there. 1, 2, 3, 4, 5, 6. So we have to remove one carbon. Okay, now it is correct. You all got it? How I have drawn 5 keto 2 methyl hexane?
Yes, ma'am.
Huh. Now you just have to do ozonolysis. Break these bonds and put their double bond O. And tell me which option is correct. One thing is clear that option number A and D are out. Right? Because they will form ketone on both sides. Yes or no? But we need one aldehyde and one ketone. Yes or no?
Yes, ma'am.
Okay. Now boy's voice came. Okay. Delete
Now
A.
option number third.
Oh, option numbers third. Okay. We will draw CH3, CH3, C double bond O. Just draw as it is. You just have to draw C double bond O. Okay. So One, two, three. But here it is two. Sorry, here it is three. We need two methyl. So correct option will be option number.
B.
Hmm. But good that you have started giving answer. Okay, understood now this question. First you have to draw structure, and for ozonolysis just break that double bond, put double bond over there and find out the answer. Okay, this is little bit not difficult but stepwise. You all are going to help me in this question. In the reaction scheme shown below, QRS are the major products. Find the correct structure. Okay, looking at arrow, when you are going from P to Q, which reaction is this? Okay, let me give you a hint. This question covers all the basics which we are covering from starting day 1 or week 1. In week 1, which reaction we have discussed apart from NMR? So,
Riddlecraft.
Friedel-Crafts. Basically, we have covered electrophilic aromatic substitution, right? Yes or no? So first step is your
Yes.
Friedel-Crafts reaction. Okay. AlCl3 will do what? Can anyone help me? AlCl3 is your Lewis acid. It will coordinate with what? Students, why this much silence?
Ma'am, oxygen of anhydride.
Oxygen of anhydride. You are saying this. Then, after coordinating with this, it has become positive. Now, next step. You are right. Now, this has become electrophile. Your benzene ring will go. Let's say you will. Okay, I'm telling you in advance that electrophile will come here, right? It can't come here due to sterics. It can't come here because it is adjacent to your tertiary butyl. Yes or no? So
Yes, ma'am.
in first step what you will get, let me draw. You can draw other groups by your own. Okay, I am just doing where changes will come here. Okay, what you will form here? C double bond O, CH2, CH2, COOH. Are you clear till point Q? Okay, let me draw other things also, otherwise you will get confused. Q is clear. How I have formed Q?
Ma'am,
Huh?
I did not understand the group that is attached to the para.
This
Means
one.
the last one. Yeah,
This,
yeah.
this this ring will open, student. Okay. Okay. Let me write here. Okay. Let's do basic. Let's say first you are coordinating your Lewis acid with this. Okay. Here positive charge will come. So in order to reduce this positive charge, this bond will break. Only a path it have. After breaking this bond, positive charge will come here, negative charge will go there. Yes or no? it
Yes, ma'am.
it will become C double bond O Lewis acid, and this CO with a positive charge. Understood? Now this carbo, what we will call it, acylium ion, this is going to attack your aromatic ring as an electrophilic aromatic substitution, and then this remaining chain is as it is, because after workup this OLA will become OH, right? Now understood? And this is your
Yes, ma'am.
acylium carbon. Clear or not?
Ma'am, clear.
Okay, very good. Now it is given zinc Hg in presence of HCl. Which name reaction? Clemenson reduction.
Clement.
Tension
Huh.
reduction. Yes, ma'am.
Clemenson, or I will say this reagent is used for reduction of which type of carbonyls? All type of carbonyl or a particular functional group? Aldehyde and
Ma'am, these
ketone.
peptides.
Only aldehyde and ketone get reduced by zinc Hg in presence of HCl. And what they will form? It will reduce this carbonyl and it will become 2CH2 were already there and 1 due to this as carbonyl is now reduced. Okay. I'm not drawing other part. You have to do this. Then in next step H3PO4 is there, students. H3PO4. Now what it will do? Again it will do electrophilic aromatic substitution. Okay. Where if I am writing this COOH, all are silent. No one has revised electrophilic aromatic substitution. Wait, this pointer is not working. C double bond O OH. Right, student? In presence of H3PO4, obviously this oxygen will be protonated. Okay. And this will leave as your H2O. And now again acylium ion will form. Okay. Now remaining position from where it can do electrophilic aromatic substitution, student? This position, right? So how many numbered ring will form? Just do numbering. One, two, three, four. I think we have done something wrong. There one, two, three carbons, na? So one carbon will also be there. So one, two, three, four, five, six. I hope you understood what I have done. Let me take fresh slide and then I will explain to you. Sorry, students, I'm not able to take new slide from it. Can you tell me where you are facing problem? Why you all are silent?
Ma'am, now we can proceed means able to understand.
Okay. Actually, my mouse is. Huh. So, students, how many member ring you will form? One, two. This carbon will be reduced as I have stated here. Three, four, five, and six. And what product you will get? Where I should write? Let me write here. Don't you think here one carbonyl will be there? Yes or no? This carbonyl. As it is having positive charge, H2O will leave and leave here positive charge. And this positive charge will be attacked by your aromatic ring. Electrophilic aromatic substitution. And you will get this structure. This is your R. Let me complete the structure. Tertiary butyl and two methyl groups. Everyone is clear how I have formed this R group? Actually, here I have written solution also. So students, I will erase this all this part. Okay. Here I have given solution also, but it is not. I am not able to erase that. Is it visible this part?
Yes, ma'am.
Huh. Now see, in first step, what happened is simple your electrophilic aromatic substitution, which I have also drawn there. Then in presence of zinc HgHCl, this carbonyl will be reduced to your alkane. In presence of H3PO4, this carboxylic acid will be activated and acylium ion will form here. So one, 2, 3, 4, 5, 6. Only position from where it can attack. Simple electrophilic aromatic substitution. And you will get this R. Now there is a Grignard reaction CH3 MgBr. Here your anion is CH3 negative. That is going to attack your carbonyl, right? It has formed this tertiary alcohol. Now you know very well that in presence of acidic media, again this alcohol will be protonated and elimination will take place from this carbon hydrogen, since there are two hydrogens. So simple elimination reaction has taken place with removal of water, H plus from here, OH negative from there, therefore double bond in between, and you will get S. Clear? Students,
Yes, ma'am.
everyone, I hope it is clear.
Yes, ma'am.
If you
What about methyl group?
what about
Methyl group, which was there.
which methyl?
There is one methyl group after
Okay,
Grignard
okay,
reaction.
I understood. In
Mhm.
problem, I think it is not there, but it will be there. Let us check that options. Yeah, it is there in option.
Option B.
Correct
Yes, ma'am.
option is option number D. Okay, good observation. Understood now, students, everyone? So, correct option is option number D. This methyl group is there. Okay, the major product in the following reaction is, which type of reaction is possible in this structure, students? Aldol, right? Two carbonyl groups are there, base is there.
Yes,
In
ma'am.
in first step, from where it will abstract proton? See, if it abstract proton from here and do attack onto this carbonyl on aliphatic side chain, it will be bridged system. Yes or no? So in order to avoid that problem, you have two chances now. You can abstract proton from A, you can abstract proton from B. Let's say you are doing this from A side. How many member ring will form? One, 2, 3, 4. So A way is deleted. From B, if you abstract proton and will form carbanion here. One, 2, 3, 4, 5,
6
6.
members.
So this is correct. Now you just do simple your aldol. It will become your OH. For your sake of understanding, do numbering 1, 2, 3, 4, 5, 6. Okay. So 1, 2, 3, 4, 5, 6. On carbon number 5, one carbonyl is also there. Okay. And on carbon number 6, one methyl is there.
Methyl group
Huh.
is there.
Very good. In second step, what they are saying, H plus heat. Now there are three possible ways. It can form double bond at A side, B side, and C side also. Let us draw all of them. If I draw in first case, I will get CH3 double bond C double bond O. In second case, if I draw double bond here, oh, I have done mistake here. Correct. Third possibility is, students, this from here, right? Now tell me, as per your opinion, which is major? Which should be major? If I look at option, I can delete two option clearly. Which two option I can delete?
C and D.
Yeah, because no one wants to form this strained four membered ring, and one is having double bond in that, which is impossible. So C and D are deleted. Among A and B, which option, as per your thinking, it is correct?
Ma'am, A
Due
should
to
be correct.
conjugation. Due to
Yes, ma'am.
because
The
conjugation
same rule.
provides extra stability to that. Student, in aldol, one thing you should observe is, whenever you are giving you given H plus heat, then only form condensed product. Okay, otherwise stick to that beta hydroxy ketone. That's why it is called aldol reaction, because product having aldehyde and your alcohol form that aldehyde plus alcohol, aldol. That's why we call it as a aldol product, and this is aldol condensation product. Okay, clear?
Yes, ma'am.
Okay, good. Now again simple question. The correct order of acidic, this question you all are going to solve, okay? The correct order of acidic strength of the following carboxylic acid is, only hint, size, electronegativity, resonance, hyperconjugation, inductive. Start solving. Shall I wait for you?
Yes, ma'am.
Okay, okay. Do take your time. In first case, what you will form? Okay. Okay. This is your sp carbon, student. This is your sp2 carbon. This is sp3 carbon. What I am talking about? This means substituent attached to your carboxylic group. And in this, though you know. Okay. Tell me the basic question, among sp2, sp3 carbon, which is most electronegative?
SP.
Sp. Why? Because electronegativity is connected with your S character, right? More is your S character, more will be your electronegativity. So, in terms, if we talk in terms of electronegativity, one thing is clear: first is more acidic than second, then your fourth. Correct? In which option 1, 2, 4 is there? In this, second is greater than 1. Wrong. Second is greater than 1. You can cut these two options. Remaining option are this. In both the option 4 is at back. Why? Because OM is plus M group. It will decrease the acidic strength. Why? It will push electron density. Oxygen is already having electron density after getting proton abstraction. Yes or no? So third option. Okay. One thing is, wait. Okay. Among B and C, which option do you think is correct? Fourth is at last because that is sp3 carbon. Okay. Can anyone tell me why third is in front of fourth? Or I can say why third is more acidic than fourth?
And because of the presence of the group attached to it, sp2.
Huh. I know OMe is plus M, but that negative charge is in with resonance to this ring, right?
Yes, ma'am.
Therefore, third is more acidic than your fourth. So the correct answer will be first, second, third, fourth. But third can't be more acidic than your second, okay? Because of presence of this OMe. Because resonance is in both cases, second and third. But this OMe is decreasing your acidic strength. So correct answer will be option B. I hope you all have understood.
Yes, ma'am.
Good. Okay, it is written. First, second, third, fourth. Yeah, we are correct. What explanation they have given? Stronger will be the acid when its conjugate base is highly stabilized. Yes, they are saying first is the most acidic, fourth is the least, since CO2 negative is attached with an sp carbon in 1 and sp3 hybridized carbon in 4. Understood? Then they are saying third is less acidic than second one because electron donating group destabilizes the carboxylate anion. Okay, the explanation is written over here. You can check. Okay. This is also interesting. NAT, what I call it, numerical based question. Tell me, or not tell me, just help me in solving this. Because today you all are silent. I don't know why. Have I brought difficult question today? But if you will solve these questions, I think you will face. You don't have to face any problem in this topic, though, at least. Okay, first step, hydrolysis. Which bond among these all the structure are most prone for hydrolysis?
Anhydride.
Anhydride, very good. Anhydride on hydrolysis forms acid. So in first step, what you will obtain? COOH, COOH. Am I clear till this point, students?
Yes, ma'am.
Okay. Then it is written, student, heating is there. You can note down in your copy whenever you are having beta keto acids, alpha beta keto acids, and you are given heat, you just have to do decarboxylation. Why? Because after getting decarboxylation, negative charge will come here, that can be stabilized by your ketone. So in heating condition, CO2 will leave, two molecules of CO2 will leave, right? And you will get this C double bond O, C double bond. Clear? First step, hydrolysis. Good, you have done hydrolysis. Second step, in heating, don't think it again will form a hydride. Sorry, anhydride. No, it will not form anhydride because now they are beta keto acids. Beta keto acids tends to undergo decarboxylation and COH will leave from both the carbon, right? Now ozonolysis. Ozonolysis will form C double bond O, C double bond O. H2O2. In presence of H2O2, it tends to do oxidative
Oxidation.
ozonolysis. Means whatever aldehyde you will get, they will further oxidize. So what you will get? COOH, COOH, and from this side C double bond O, C double bond O. So what they were asking, the total number of carboxylic acid groups in the product P is. How many carboxylic acids are there? Two.
Only two.
So two is the
Two.
correct answer. Understood how to approach these type of problems? Okay.
Yes, ma'am.
Let's say you don't know anything, nothing is clicking at time of exam. So what you should do? In first step, it is written hydrolysis. So only possible bond that can break here is this. Okay. Then it is written heat. Then you will think that two carboxylic acid ortho to each other uh, uh, will undergo what I will call it dehydration, and will lead to will lead to formation of anhydride. But you will get back to your starting material. Then you should think, no, something different will happen here. Why? Whenever you are having beta keto acid, they will undergo decarboxylation. So basically, you have to do decarboxylation. Then O3. You know that ozonolysis reaction occurs on olefin only. So this part will remain intact, and after ozonolysis you will get aldehyde here, right? But H2O2 is also there. It will further oxidize your system and will convert into 2 carboxylic acid. Simple. Understood? This is the way how to solve an unknown problem in your exam. In your exam you will not get question on this or similar question to this, but you should remember the pattern how to think. Okay. Okay, it is written, solution is given here also. Let me erase. So first step is, student, simple your hydrolysis, then your decarboxylation, then your oxidative ozonolysis, and this will be your product. Understood?
Yes, ma'am.
Good. Okay, in the following reaction, compound Q is obtained from compound P via an ionic intermediate. Okay, take this as your homework. I think you all are bored. No one is taking part excitedly like last class. Take this your homework. I will suggest don't see solution. First try to do by yourself and then come to me. Okay. Okay, but let us read this question. Compound Q is obtained from compound P via ionic intermediate. Okay, okay, okay. By looking at question, what do you think? This is from which topic? Aldol, not electrophilic aromatic substitution. Okay, think about this. Come in next class and please remind me. We have to solve this question. Okay, reagent which can be used to bring about the following transformation. Okay, so students, three functionalities are there. Okay, this is your ester, this is aldehyde, this is your acid. And in product, they want that ester should be as it is, acid should be as it is, only aldehyde should do. So, which
Weak,
can be correct option?
reducing agent.
Okay, among these, which is most appropriate?
Aldehyde.
One thing you should remember, everyone, LAH, lithium aluminium hydride, it can reduce every functional group. Every means your aldehyde, your ketone, your ester, your amide to alcohols. It converts everything into alcohol. So if you want selectivity, you should never go after your LAH. So option A is deleted. And BH3, if you are taking this Lewis acid, they will first reduce your carboxylic acid. Remember, whenever you are taking electrophilic hydride source, I will briefly tell you the story behind this. They will first choose your amides, then acid, then your aldehyde ketone. Why? How they react actually, students? Let's say you are having this COOH. What they do, BH3 is your Lewis acid. Why? Because they are electron deficient. So first they will coordinate with your oxygen and brings positive charge on oxygen and on themselves negative charge, right? Now internally they will transfer their hydride onto this, like this: OBH3, sorry, BH2 HOH. Understood? So among these carbonyl, on which carbonyl they will go? Obviously, which is most electron rich carbonyl, right? So oxygen lone pair can push there, and we know that among amide, acid, and aldehyde ketone, this carbonyl is most electron rich for this incoming electron deficient Lewis acid. Yes or no? So whenever you are having electrophilic hydride source, your reactivity pattern will be in this way. Amide will be reduced first, then acid, then aldehyde ketone. Okay. Correct option is, student,
Option
NaBH4. NaBH4 can reduce aldehyde and ketone only. Okay. If I am able to add new slide, let me teach you one thing.
Ma'am, why can't we use Ran and nickel here?
Okay, I will tell you. I don't know why I am not able to add new slide today. Hmm. Basically, raninical is used for a reduction of double bonds, right? You can't reduce carbonyl by H2PDC or H2 raninical. H2 raninical are basically used for removing your, let's say you have CSPH bond, carbon SPH. There it can reduce, or it can reduce your thioacetals. H2 raninical can reduce your double bonds, but not your carbonyl. Okay. Have you studied anywhere that people are using H2 raninical condition for reduction of aldehyde ketone?
No, ma'am, did not study, but just now I
Okay,
was going with
asking.
what Ran and nickel and
See,
then I saw something in the internet only that there is a reaction where it is converting aldehyde to primary alcohol and ketone is getting converted into secondary alcohol.
by using H2 raninical.
Yes, ma'am. That is why I asked you.
But I'm saying you it is least preferred reagent, because I'm also a chemist, organic chemist. So whenever we want to reduce this functionality, aldehyde to alcohol, we don't use H2. I think in some cases they are preferred, but uh, if you are given H2 PDC or H2 platinum, etc., I don't think they will be able to reduce carbonyl to alcohol. Basically, what is the mechanism? These metal provide surface to your hydrogen. Hydrogen, in which form you take hydrogen? Hydrogen balloon having hydrogen gas in it, right? So these metal provide space to that. Only they are like your plates, okay? Plate in which your hydrogen gas is embedded, okay? And then it transfer that two pair of H2. रुको. Let me draw. Let's say this is your metal plate. Okay. Here there are surfaces on these metals in which hydrogen gas gets adsorbed, not absorbed, adsorbed on surfaces. And what it do now, it just transfers H negative in a concerted way. Sorry, this is your H2. This bond breaks and this new bond forms, and you get simple your alkane. This is your mechanism for H2 ranenical. But if you are saying you get this example, I will read about this and will tell you in next class. but
Okay.
this is the least preferred reagent for reducing of carbonyl groups. Okay, this I can tell you for sure. So NaBH4 is going to reduce your aldehyde ketone. So from this slide, what I want to tell you is that if you talk about reactivity of carbonyl groups, which is most reactive carbonyl group for reduction? LD, L, wait, aldehyde is your most reactive, then your ketone, then your ester, then your acid, then amide. When when your nucleophile is your when they're hydride based reducing agent, right? For example, NaBH4, LiLH4. But whenever you are having electrophilic hydride source, order will be this. Why? Because now your that BH3 is first going to coordinate with your carbonyl, then it will transfer hydride. But in above case, it directly transfers hydride. So more the electrophilic will be your carbonyl, faster it will transfer hydride to that carbonyl. Okay, let me repeat. More the electrophilic will be your carbonyl, faster hydride will attack onto that carbonyl. So whenever hydride based reducing agent, order will be in this way: aldehyde, ketone, ester. And whenever you are having electrophilic hydride based reducing agent, your order should be amide, acid, aldehyde, ketone. Let's say I am adding BH3 in this case. Which among these three carbonyl, which will be reduced on priority basis? Your acid. Okay. Are you getting what I am asking? Let's say on arrow I am writing BH3 in THF. Among A, B, C, which carbonyl will be reduced faster?
C carbon.
C. Because first it will coordinate with your carbonyl and this is most electron rich. Okay, good. Which of the following reactions will form an epoxide in presence of peracid such as MCPBA? So the following reactions will form an epoxides. Okay, epoxides. They are asking which functional group can undergo epoxidation? Alcohol, ether, alkene, alkyne. They are asking among these four options which can undergo epoxidation. Obviously, alkene can undergo, right? If you are having epoxidizing agents such as MCPB, obviously it will form this. Why not on alkyne? Because alkyne, if let's say on alkyne it is doing, it will form this and this will be highly strained system, right? So the correct answer is option number C. You can't form any, let's say you are having OH. From where you will do epoxidation? Nowhere, right? So the correct option is alkene. An ether is more volatile than an alcohol having the same molecular formula. Why? Okay, this so you can tell. They are
Yes, ma'am.
saying why ether is more volatile than an alcohol. What extra thing alcohol is having than your
Ma'am,
ether?
intermolecular hydrogen bonding in alcohol.
Very good. Actually, hydrogen bonding keeps molecules attached to it, right? So they will be in liquid form. But ethers are not having that advantage of having hydrogen bond. So they are volatile. I hope you understood. So intermolecular hydrogen bonding in alcohols is region. Why? Okay, simple thing. Your H2O is having molecular formula 18, but can you evaporate H2O readily?
No, ma'am.
In real life, yeah, H2O evaporates easily. But if you are working in a chemistry lab and you are given, let's say, methanol and you are given methanol leaf, let's say you are having ethyl acetate, you are having water. Ethyl acetate is having more molecular weight than water. But H2O is difficult. okay, for getting evaporated by your rota evaporator instead of ethyl acetate. Ethyl acetate will, okay, this is your ethyl acetate, right? This is your not. Now it is ethyl acetate. Okay, and this is your H2. Since water is having 18, molecular weight of water is just 18, but still it is not volatile. Why? Because molecules of water are attached to each other via hydrogen bonding, and they will be in cage like structure. Means they will form this intermolecular hydrogen bonding, and they will not be so easy to getting evaporate. But these molecules are like ethers, they don't have any interactions like this, therefore they are volatile. They don't coordinate with their molecules. Let's say you are having other molecules of your ether, how they will connect? No such intermolecular hydrogen bonding there, so no interaction, they will evaporate easily. Interactions make them liquid.
Yes, ma'am.
Good. So I will take this as a last question. Other question you will take it as a homework. How many questions are there? Okay. I will explain to you this question, and you can solve problem number 17, 18 by yourself. Okay. If any problem you face, just tell me next class. I am only telling you this question. Just tell me the if you recall the name of this rearrangement. What it is? Have you ever studied pinacolon rearrangement?
I'm heard about it.
Okay. So basically, student, what you have to do? CH3, CH3. Okay. Since this is symmetrical system, it is easy. H plus is there. Obviously, H plus will go to one of the hydroxyl group. After coordinating or after attaching to H plus, this will become OH, H2, H3O positive. Sorry, H2O positive, right? Obviously, after forming this, it will leave it as a H2O molecule, leaving behind carbocation. CH3, C, CH3, OH, C, CH3, CH3. Positive. Clear till this point? How I am forming carbocation?
Yes, ma'am.
Okay. Now you know that carbocation tends to undergo rearrangement in order to get stabilized. You know
Yes, ma'am.
that OH can stabilize it. So how it will stabilize it? This 1,2 methyl shift take place. 1,2 methyl shift. So if methyl will shift here, it will leave behind carbocation there, right? And it will be like CH3, CH3, CH3. Now so it's simple. Oxygen will go there and will form this product. Correct?
Yes, ma'am.
So nothing happened here. First, your one of the hydroxyl will be protonated. Then H2O will leave. It will leave behind carbocation. 1,2 methyl shift. Methyl shift means CH3 negative. If it will leave here as CH3 negative. It will leave here positive charge, which will be adjacent to oxygen. If we compare this structure and this positive charge is more stabilized as it is near heteroatom having lone pair, and at last this oxygen will go back and will form ketone, and you will get this ketone product. This is your pinacolone rearrangement. I just for sake of understanding, I've told you it will. You can consider it as CH3 negative is going there, leaving behind is positive charge. But this is considered 1,2 methyl shift. Okay, this methyl will come here, leaving behind positive charge. Understood?
Yes,
Yes,
ma'am.
ma'am.
Okay, but question is something else. They are asking which of the cation A to D is least likely to be an intermediate in this reaction. Okay, this though it has formed. Okay, we have
Possible.
discussed. Yes.
C is also possible.
C, yeah, C is also possible.
Yes,
A is also. B is can't possible. B can't be possible. You can't form this positive charge on adjacent carbons. Okay, so they are asking least likely. So B is the correct answer. And this also we have formed here, right? When it will assist this positive charge, it will form double bond OH, right?
Yes, ma'am.
So correct answer is B. Good. Okay, let me help you in solving this. How will you form this? Tell me. I have told you about diazotization reaction, student, that NH2 convert into N2. I will tell you this question also because I don't think you know about ring expansion or ring contraction. CH3, after getting NaNO2 HCl, NH2 group convert into N2 positive. Yes or no? In diazotization, we have seen this thing.
yes,
Huh. Then N2 will leave and it will form carbocation here. Obviously, carbocation is not stable. Okay. Before studying this topic, you should know how to see stability of carbocation. For example, for conjugate base, I have told you a sequence. See size first, then electronegativity, then resonance. For carbocation, student, you should see mesomeric, aromatic, resonance. Trick for this is mar. I have not told you any trick in Hindi, but just for remembering purpose, mar hi daloge means mesomeric, aromatic, mar. Mesomeric, aromatic, resonance, he, hyperconjugation, and then your simple inductive, mar he. Okay. How you have to see? Let's say you are having this, and let's say you are having this carbocation. First carbocation is stable as this carbocation is bringing aromaticity here. 4n plus 2 rule, students. Every carbon is sp2 hybridized. 4n plus 2 it is following. If you put n is equals to 0, it is following Huckel rules of aromaticity. Due to
yes,
this carbocation aromaticity is coming. So among, if anyone asks you which carbocation is more stable, you will say that A. Why? Because if you go by this order, mesomeric not aromatic, yes, it is stable via aromatic, and this is stable via resonance. So A is more stable than B. But let's say I am giving you C positive OMe and this. Now tell me which is more stable among A and B. Obviously A. Why? Because this is stable by mesomeric. Mesomeric effect is assistance of lone pair of electron on an electron deficient species. Right? So A is greater than B. This is general organic chemistry concept. I hope you understood.
Yes, ma'am.
You have to see in that order: mesomeric, aromatic, resonance, hyperconjugation, inductive. And one example is there which is stable among all this order, which is cyclopropyl cation. This is thousands of magnitude higher stable carbocation than your mesomeric aromatic. Okay, why? You should read at your home. We will discuss. Okay, this cyclopropyl cation is most stable among all this because this ring, I'm giving you hint, this ring is strained. It wants to open up, and it will open up with the assistant of this carbocation or positive charge. Okay, how it will open? It will bring here negative charge, here positive if this bond will break, and in order, and due to this positive charge, these three strained ring can open up. That's why this carbocation is stable. Okay. In organic, on what terms we assign this thing, stable or unstable? Anything that can decrease this positive charge brings stability to this carbocation, right? Yes or no? Student?
Yes.
Okay. So in this, let me erase this part. I hope you have noted down in your copy this. Huh. So how will you approach this question now? I have told you how to see stability of carbocation. Positive OH. You know mesomeric can stabilize it. So anyhow you have to bring positive charge here. How you can bring? Either you can break this bond or you can break this bond. Let's say I am breaking below bond. Actually they are symmetrical. So positive charge will come here, negative charge will come here. Okay. This I am explaining to you just for understanding purpose. You don't have to break like this. I hope it is clear. Clear? Now this positive charge and negative charge will combine. One, 2, 3, 4, 5, 6, and you will get 6 membered ring. Just number it 1, 2, 3, 4, 5, 6, and one carbon. On carbon number 1 methyl is there. Second carbon OH is there where positive charge is also there. Third, fourth, fifth, sixth. Yeah. Oh, sorry. One, 2, 3, 4, 5, 6. Correct? And then at last it will form here ketone. So correct option is D. Understood, students? This intermediate I have drawn just for sake of understanding. You have to do like this. In order to bring this positive charge stability, what you have to do? You have to break this bond. How? Because if you break this bond, positive charge will come here that can be stabilized by mesomeric effect of OH. Positive charge will come here, negative charge will come here. Draw in your copy right now, then only you can understand. This newly formed negative charge will combine with that positive charge. Why? Because among these two, this is stable. This can live it in this positive form, but this can't. So it will form this six-membered ring, and on the second position, OH is also there. That will form ketone, and you will get ring expanded product. I hope you have understood.
Yes, ma'am.
Sure. If
Yes, ma'am.
yes, if yes, do this question. This is also your pinacolone rearrangement. So, student, this is your summary of carboxylic acid. What reactions it can undergo. You just go through this table, revise it, and we will discuss it in next class. Okay. Now tell me what doubts you are having. Main doubts. Tell me where you are getting problem in solving. I think in acidic strength everyone can do. You just have to make conjugate base, see its stability in sequence, size, electronegativity, resonance, hyperconjugation, inductive. Okay. Then we have covered questions based on reducing agent. There are two types of reducing agent: hydride based, electrophilic hydride based. Okay. Then we have discussed about pK and all. That higher is the acidity of your compound, lower will be its pK, because pK is inversely proportional to Ka. Okay. Then we have today we have covered mechanism of Remer-Temin reaction, which goes via formation of this active carbene species. Okay. If anyone asks you in a competitive exam, what is the reactive intermediate in Remer-Temin reaction? You should say carbene, dichlorocarbene. So first phenolate ion will form. Phenolate ion will come back. Negative charge will come here. It will attack this carbene. Carbene will still have this negative charge. This then intramolecular proton transfer reaction will take place. If H plus will leave here, negative charge will come here. H plus will go there. Okay, and then this 2 chlorine will be substituted by your OH groups, and at last you will get this salicylaldehyde. I'm just revising the things. This type of question you can do by finding degree of unsaturation. Ozonolysis, you just have to break that double bond, bring and draw that ketone. Okay, this you can go through again. Acid strength you have covered. Other thing that you think I need to discuss is tell me.
Ma'am,
Huh? Ask.
ma'am, there is a question from week 3 assignment. Can I ask that?
But I don't have those questions. Can you?
No, I'll just tell you.
Okay, okay. Ask.
Ma'am,
Huh.
yes, ma'am. Ma'am, there was a question where it was written in hexane 2 for dione, how many
Hmm.
different monoenols are possible? While
In
solving this question, I had two options in my mind. It can be hexane 2 for dione.
wait. You were saying hexane 2,4 dione, na? Wait. Hexane, simple
Yes, ma'am.
hexane. Okay.
Simple, not cyclic.
Okay, sorry. One, two, three, four. Correct. Huh. So what was the question? How many
Yes.
monoenols were possible?
How many different monoenols are possible? So, ma'am, while solving this question,
Okay.
there was two options in my mind. As the in the question, four options are given: two, three, four, and seven. Ma'am, on the basis of just seeing the uh, on the basis of just finding different structures,
Mm-hmm.
there was four in my mind. But later, there was also point where considering cis, trans is at
Yes.
that.
See,
So there was seven.
how to
So
approach
when to
these.
decide what?
Okay. See how to approach
Yes, ma'am.
these type of question. First, you should see whether this dinon is symmetric or asymmetric. But it is not symmetric, right? Because it at this side methyl is there, this side ethyl is there, right? So, first possibility is that this ketone can have enols from A side, B side. Two possibility, right? This let's say carbonyl 1 can have two possibility from A side, B side. Carbonyl 2 can have two possibility from C side and D side, right? Now other possibilities are there. A a can't be in two forms. Let's say you are forming this C double bond O negative. This can't be in cis transform, right? Because they are having same substituent HH.
Yes, ma'am.
But another one, let's say you are having this type of, let's say R group is there. But this can have cis trans, right? With respect to this hydrogen. So one possibility, one and two possibility. That's cis or trans. So one and two are possible from here. Okay. And in another, let's say you are doing this O negative, this R group. This can also have two possibilities. And from this side also it can have two possibilities. So 2 to 4, 5, 6, 7. So I think correct option 7. No?
Yes, ma'am.
You have understood how I am solving this. Yeah.
Yes, ma'am.
I-
I knew that there will be seven also and this four also. Considering cis
okay.
trans in this one,
Okay.
there will be seven.
Huh.
So I was
But,
not able to decide which option I should
huh.
click.
See, let's say in this question examiner has given you option 2, 3, 4, 5. 2, 3, 4, 5. Then among those options you should choose 4, because then you should understand that it is not asking about ez, but since it is giving option you 7, it means they are considering ez also a separate products. Generally in
Yes.
these type of question they consider ez as different enols. Okay, they consider.
Okay, ma'am.
So you should see among options. Then you can decide. But you understood now why it can only have one, because these two substituent are
Yes,
same.
ma'am.
In double bond, you can have two different types of nomenclature. Cis trans, when you have AB type system, right? AB type system. That these two are cis or these two are opposite. That are cis trans. But let's say you are having this type of system A, B, C, D. Then you have to choose priority. Let's say same priority groups are on same side. Then that is Z, ZL key. Same priority groups are on different side. That is EL key. Understood? About
Yes, ma'am.
nomenclature. I hope everyone understood. Okay, student. This is all for today's class. Thank you for joining. If
Thank you,
if you are
ma'am.
having any doubt, you can ask me next class. Thank you.